As our attendees start to come in. Lovely to see you. Welcome everyone to this month's episode of Ammonia Energy Live, where we explore the wonderful world of ammonia energy and the role it's going to play in global decarbonisation with a bit of an Australian twist. First of all, I want to acknowledge the traditional custodians of the land upon which we meet, and I pay my respects to elders past and present. I'm coming to you from lovely Wurundjeri country in Melbourne. I extend that acknowledgement out to country wherever you are in Australia and indeed around the world. So, safety. It's a critical issue that we've explored before on this show, and it has so many facets. SOPs and PPE for frontline workers, engineering controls, training controls, regulatory controls of all shapes and sizes, with things to do with storage, transport and pipelines, and the list goes on. And that's before we even get to the public concerns with proximity to hydrogen and ammonia. So it's a small topic. We're going to look at some of the key considerations today for safety engineering for some future ammonia energy solutions: offshore maritime, onshore maritime, large-scale storage and power generation. So in order to explore all this, we're joined by Laurentiu Zamfirescu, the Principal Engineer in the Safety and Risk Engineering section at AMOG Australia, and he's based in Perth. A very warm welcome to you. Please submit your questions via the Q&A function. You see it at the bottom of your screen. You can upvote and comment on each other's questions if you wish. We have a number of very good pre-submitted questions lined up for our Q&A today, and I encourage you to keep on sending them through when you register for future events. We'll also put a recording of today's session up on YouTube ASAP after we finish, so that you can share with people. So let's get into it. So hi, Laurentiu. Great to have you here. Firstly, can you introduce yourself and can you tell us what it was like the first time ammonia energy crossed your desk as a safety engineer? Did it raise your eyebrows or was it just another problem to be solved?
Yeah. Okay. Thanks for having me, Julian, and I'm happy to be able to contribute through the Ammonia Energy Association to the safety of the clean energy revolution, to say so. So as a brief introduction, I have been working as a risk and safety engineer and process safety professional for 15 years. This was both in Europe and Australia, and 4 out of these years I've been a safety regulator for major hazard facilities, and for the past 5 years I've been working as a safety consultant with AMOG. I hold a number of professional certifications and registrations, which I won't mention here, mindful of the time and our audience. So the first time I came across ammonia was when I was starting my regulatory career, and I was a government inspector back in Romania. We had in our hometown a fertilizer manufacturing facility, and during that, the initial inspection, I came across the massive 40,000-ton ammonia storage tank. So I can say it was a humbling experience, as I knew the extent of the consequences that can happen should things go wrong. And to put that further in context, one of my responsibilities there with the regulator, which was similar to what a fire is do here in Australia, was emergency response planning should there be an event with offsite consequences. And now if we're to come to contemporary times, we're trying to solve some of our CO2 minimization targets by using ammonia as an energy source. Look, it's a great solution. However, in comparison to the other alternatives, I'd say ammonia demands additional respect and careful consideration because of its toxicity.
Excellent. So that's you, but what about AMOG? What's your organisation's background in the hydrogen and ammonia space? Is there anything Australia specific?
Yeah, so AMOG stands for Australian Maritime Offshore Group, and AMOG specializes in solving complex engineering problems, and the company has been around for 30 years. The headquarters is in Melbourne, and what is different about AMOG is that we bring a mix of knowledge, skills, and experience covering both technical safety, the one we were talking about now, and this is both onshore and offshore, as well as maritime and naval architecture. So on the maritime things, we deliver safety scopes of work for defense ships, as well as offshore oil and gas platforms and vessel. If we go onshore and we talk about onshore safety in an ammonia context, we've assisted several Australian ports to understand their risk profile and what future developments they can pursue. For example, ammonia bunkering or establishment of import-export terminals. We've also had dealings with ammonia development proponents and assisted them in the early project phases, as well as looked at refrigeration system. So our engineers have design, commissioning, and operational experience in production and ammonia storage facilities. Now, if we talk about hydrogen, just in its pure form and not transformed into ammonia, we've conducted research into accident causality to understand how do things go wrong with hydrogen and how to take those learnings and implement them into project safety plans, as well as hydrogen handling as an intermediary during ammonia production.
Excellent, excellent. Great to hear that you've already been doing some work with Australian ports. So, safety, small topic for a Thursday afternoon. Where do you even start with ammonia?
So the good news is that ammonia is nothing as a material, as a dangerous goods. Ammonia is nothing new to the engineering world and also the management of safety. Ammonia has been around for about 100 years. Now, if we're to compare this to some of the more commonly known chemicals such as hydrocarbons, and this is where gasoline and diesel, LPG, LNG, and then also on the chemical side, chlorine and fertilizers, ammonia has quite a good worldwide safety track record. But we do face the challenge that this track record is challenged as we're now looking at a more intensified industry where the demand for ammonia will grow. So this may be either through traditional ways of manufacturing ammonia, such as previously not being applied to mass production scale for green ammonia. Now, if we consider ammonia as a fuel, especially for the maritime industry, there's quite a significant difference in regards to risk and controls based on the mode of storage, either if you do it pressurized or cryogenics. So these two applications vary quite significantly and require different controls. So to put this in short, where you start with safety and the current applications, we can see there's we can consider two spectrums. One is onshore developments, and the other one would be offshore maritime applications.
Interesting, interesting. We've got your audio feed. We're having a few problems with your video feed, but your audio is coming through strong, so that's all good. We'll keep going with the conversation. We'll go back to applications in a minute, but I'd like to first get you to think about comparing ammonia with our current selection of fuels. What are the key safety differences, and are there things we sometimes overlook in this comparison?
Okay. So obviously there are differences between ammonia and the current selection of fuels, and this is where we can consider gasoline, diesel, biodiesel, LNG, LPG, and these are both differences, positive and negative differences. Obviously, we want to use ammonia to reduce greenhouse gas emission. That one is clear, but I'll focus just from the safety perspective. So a positive safety aspect in comparison to those other fuels is that it does not burn as easily. So the flammability and the explosive hazard is lower. This obviously makes it a challenge to design engines for ships and have them run reliably. But from a safety perspective, it's a positive. Now, it is the toxicity of ammonia that makes it a different challenge in comparison to solid fuels. And this toxicity is twofold. One is toxicity to human, and the other one is toxicity to aquatic life if we have an ammonia spill at sea. Now, in regards to things being overlooked, I'd say one thing that is commonly overlooked, and this is primarily in onshore projects, is the compatibility with a neighboring land use. And this means providing sufficient separation distances between your plant or your storage area to sensitive users such as residential establishments. The other activity that is somewhat overlooked is implementing identifying and implementing all the safety activities within the overall project design plan. So based on this potential land use incompatibility, some of our existing ports may be unsuitable for ammonia activities. This is where we'd either be considering bunkering or an export terminal. Something as well that we've seen would be overlooked is ammonia pipeline routes and road transport risk. And this is obviously the risk again varies whether it's pressurized storage or cryogenic, transport, pressurized or cryogenic. So because these aspects of transporting the ammonia form part of the overall project risk, they need to be considered. It's not sufficient that we look at the risk of producing it and look at the risk of exporting it or using it at whatever end user we have. So you also mentioned about some novelty. So if we were thinking of new things and what is new with this energy transition that we're going through, I would say maritime bulk transport of ammonia is quite well established. Even in Australia, it's been happening for 20 to 50 years. However, ammonia as a fuel for ships, as an energy material, is something novel.
Excellent. And we'll draw out some of those details about spacing in our Q&A. Very, very hot topic. Move on to applications. You've already mentioned onshore and offshore maritime safety. So what are the key differences between those two? And is ammonia in one easier versus the other?
Right. Okay, good question, Julian. Thanks for that. So onshore safety is about, to call it so, and this is an arbitrary demarcation, but I think it makes the conversation easier if we make this demarcation. So onshore safety is about land-based applications, and this is where we're talking about production, transport, storage, the infrastructure you need in a port for ship bunkering, and then you'd have import-export terminals if you want to transport ammonia at long distances on sea. Now, the offshore and maritime safety is about that sea transport for ammonia and the novel application of using ammonia as a ship fuel, as an energy source. So there are obviously challenges in both areas. However, onshore safety is far more established. We've been doing this as an industry, we've been doing this for quite a long time, and the standards and the regulatory regimes are quite well in place. However, a challenge is being put forward by the proliferation of ammonia as a fuel, which will require large storage volumes than typically used in refrigeration system, which is one of the more common applications. Now, for one of these onshore challenges that is new would be long distance transmission through pipelines. And this is especially so if proponents choose to use cryogenic ammonia versus pressurized ammonia. So between these boundaries of onshore and offshore, we have ship transfer from an onshore facility, being either for bulk transport by cargo ship or for bunkering of the vessel, so it uses it as fuel. So as we said, ammonia cargo ships have been safely operating for quite a while now, and we would use that same technology or very similar for shore to vessel bunkering. One of the very brand new safety challenges in the maritime offshore space would be vessel-to-vessel bunkering when using ammonia as a fuel for the ship.
Okay, interesting. Can you tell us more about the maritime power generation space? Sounds interesting. We've seen it pop up in Singapore, but it must be really, really new. There must be lots of challenges and unknowns.
Yeah. Okay, so you are correct. It is a new application, and there are significant engineering challenges in regards to making engines run on ammonia and the associated boil-off system, and challenges in regards to materials if using cryogenic ammonia, and this is where cold embrittlement can crack normal carbon steel. However, the management of safety is less of a challenge, I'd say. So the safety principles for ammonia on ships are not complicated nor different to other onshore industries and application. There is, though, a big however. For the moment, a commercial design hasn't been accomplished yet. So both DNV and ABS have already established requirements for ammonia-powered ships, and this takes into consideration all those onshore safety principles and learnings we have learned over the past 100 years. The challenge, however, is taking those requirements and the knowledge we have and actually implementing them into a new application. So some of these specific ship-based challenges are related to management of leaks in close environments. This is likely to result in a more expensive application, as we would require either materials that withstand low temperature and requirements for secondary containment, i.e. a pipe-in-pipe design. Then the layout and the general layout of ammonia storage and delivery systems and separation from personnel on ships would also be required to address. And nonetheless, I would say because we need high reliability and availability of the propulsion system for these ships, we cannot afford ourselves for the engine just to cut off. There will likely be the requirement for redundancy, and this is where we duplicate the ammonia fuel delivery system. In case the primary one goes down, we have a secondary one. But there is good news. There is good news. So the good news would be that there is extensive knowledge and experience in handling ammonia, and it is not completely new territory, as is the case of cryogenic transfer and use as a fuel, or then mobile hydrogen storage and its use as a fuel.
Excellent. There's some great technical details there, quite a bit that I had not thought of. So very, very good to cover that.
I hope they didn't go ahead and it was the right level.
No, it's very, very important. Just before we change tack, let's just talk quickly about ammonia storage, especially at large scale. It's something a lot of our members face, especially fertilizer producers. What are the key issues with large scale ammonia storage in Australia, especially?
Yeah. Okay. So look, we've been doing large-scale ammonia storage for many decades, and luckily it's been with very few worldwide incidents. So the issue is that if an incident takes place, the consequences can be very severe. So ammonia can travel considerable distances from the point of release being carried by the wind. So the way we manage this hazard is by locating such storage and production facilities away from populated centers and sensitive developments. And this is schools, hospitals, residential areas, aged care, etc. Now, the challenge is twofold. One is the intensification of the projects, which we will see more of these facilities pop up, and we need to take into account the limitations of the land available and what's in the vicinity. And the other one is obviously wanting to use ammonia as a ship fuel. So for onshore to ship bunkering, this would see ammonia tanks required to be placed in ports. Now, however, quite a number of Australian ports are surrounded by residential developments, making bulk ammonia storage incompatible. Now, there's also good news. If we look and we consider ammonia trading through import and export terminals, these establishments can quite easily be developed away from sensitive areas, as you know, Australia is blessed with sufficient uninhabited space. But for ports, there is a challenge indeed.
Interesting. Let's draw this together and start to discuss some solutions. So I'm interested in your view. Do we have all the technical and regulatory pieces in place for a safe ammonia energy industry, or are there things that are missing?
Okay, so I'll be talking on the regulatory side of things. I'd be referring to what we currently have in Australia, as these regulatory requirements differ from country to country, and I'm not abreast all of them. So I'd say most of the technical knowledge and regulatory requirements are in place. Perhaps one of these missing pieces of the puzzle is in regards to waterborne ammonia spills. And this is where the environmental impact of such accident is significant, because ammonia dilutes in water, and you cannot respond to such an event in the same way as an oil spill, where you just box it in and then put neutralizer on top of it. Now, if we focus on the maritime industry, both DMV and ABS have published rules for ammonia-powered ships. These identify the safety requirements and the design process to follow. So from a safety engineering perspective, there isn't really nothing new in comparison to an onshore facility handling or processing ammonia. However, I say this with a however, because commercialized vessels have not yet been achieved. We know what we need to do. It's another matter of actually being able to do it and do it in a commercially sensitive way. A new application is the ship-to-ship ammonia bunkering. Now, this brings significant challenges, and it's rather new territory, but I understand that there are projects that have received approval in principle from classification societies. However, the road is still ahead of us. So why I mentioned this ship-to-ship ammonia bunkering, it is because it's a potential solution to our land use safety planning. If we cannot place these facilities within ports because they're surrounded by residential areas, then we can simply do the fueling at sea, and the actual terminal where our bunkering vessel will fill up would be somewhere further away from residential areas. Now, if we talk about onshore safety, and this is bulk storage and also bunkering, all the requirements are in place. You know, Australia has been doing ammonia cargo filling successful for 20-30 years. and we would simply apply that same technology to onshore bunkering if we're talking about cryogenic systems. And then if we're looking at using pressurized ammonia as a fuel on ships, we would be using the experience we have from LPG transfers. You've probably seen around town that so many trucks carrying LPG around, so you haven't heard many of them going wrong.
True. Excellent. All really, really good messages. So without giving away advice that you do charge consulting fees for, what are the key messages for project developers?
Right. Look, I'd say ammonia can be safely managed onshore as it has been done for close to 100 years. There is obviously intensification in its use, which will put further constraints on land use planning. However, there aren't really any new technical challenges except for long distance delivery through cryogenic pipelines. That's something new. Now, the maritime space is indeed a new challenge. So, on one hand, we have the challenge of engines actually running on ammonia, but it's not necessarily related to safety. So, for technical safety on ships, we know what we need to do. We have the rules in place. We have a lot of onshore experience. However, we need to apply that and have successful commercial designs. As I said, the ship bunkering is a new challenge. However, we can draw on experience. So if we're to go with one message on top of, yes, onshore, we've managed ammonia safely for a long time, I'd say engage a technical safety professional early in your project to understand your risk and the proposed control measures, and this will help you identify any red flags and properly plan and assure the entire project. So the earlier you do this, the less rework you need to do, and this obviously contributes to the project success. And one thing we need to keep in mind, and it's related to this one, is that an incident in a newly developing industry can change the track of the entire industry and significantly reduce investment appetite as well as public and regulatory trust. So doing the right thing from a technical safety perspective is not just for your own projects. It is essentially for the entire future of the industry.
We need to be proactive. Great message here, and I think it's a great message in general. Excellent. So in 5 or 10 years' time, where do you see the state of play with hydrogen and ammonia? Accepted, safe, mitigated, under control, or still acceptance issues?
Okay. So we're lucky ammonia is well understood and accepted. There will be pilot installations and early phase adoption. We are also likely to see an increase in import and export terminals and the use of ammonia in power generation, perhaps even land-based application. So ammonia-powered ships are likely to see quite a good adoption. It's very unlikely that this will be for passenger transport, as the risk may be too high. So pressurized ammonia systems can be applied as retrofits to existing ships. However, cryogenic ammonia as a fuel source on ships is likely to only be possible for new ships due to a number of safety issues. So, and hydrogen, yes, hydrogen definitely has a space. It will have increased local applications as fuel stations and cars and buses and local grids and potentially even household power generation. And I'd say this is somewhere where ammonia can't readily compete due to its toxicity. But as we know from our experience in ammonia production, hydrogen is difficult to handle and to store as an intermediary, and requires lots amounts of energy to liquefy and store. This is why large-scale liquid hydrogen storage and transport is still quite far into the future. So why this is difficult? Because the liquefaction temperature is 20 degrees above absolute zero, and this makes it a huge challenge and difficult to overcome. So I'd say from a bulk perspective, I'd say this would make ammonia the winner, if I can use that term. So there will be space and there will be projects for both ammonia and then hydrogen, but the applications will be different.
You can certainly use that term here. More than welcome. So, okay. What can the AEA and our wider network do to accelerate safety developments?
So I don't know. I hope this doesn't sound like a high horse approach, but there shouldn't be a trademark on safety or for safety to represent a competitive industrial advantage. It's the only way we can learn and evolve. So if projects share their learnings and definitely their failings in regards to these applications, well, then the whole industry benefits and the process is accelerated. So something that perhaps AEA would be able to do is organize a safety conference to provide for an avenue for these discussions to take place. So as the maritime industry is in the early phases of adoption, the industry should also involve specialists from other industry sectors that have managed these problems before and then have the expertise. So this cross-learning and collaboration would be something definitely that would work well.
Excellent. Thank you very much for all that. Thank you very much. We'll move on to some Q&A now. We've got a couple of good pre-submitted questions and a couple of live questions to answer. I'll start with one from Manu at Mainspring Energy in the US. And this is the details about space clearances. What are the space clearances for safe ammonia operations from storage tank and end-use engine? Is what he's asking about.
Use engine. I hope that, or I presume that Manu is referring to a ship running on ammonia, and that would be the end-use engine. So the DNV rules that are currently in place only provide separation distances from the ammonia storage tank to the shell of the vessel. So in case of an impact, that storage tank would not be affected, but only require separate compartments between the storage tank and the engine. So there's no specific distances. If we're thinking about separation distances between onshore ammonia tanks and sensitive users, we have Australian standard 2022 that provides those distances based on the quantity, and then obviously there is always consequence modeling and quantitative risk assessments to provide us a better response.
Okay. Excellent. We'll move into a couple of incident questions now. So Krista, who's here live from the US, asks if an ammonia spill on water does happen, what's the basic procedure there?
So it's, yes, that's a complicated one, and it's still in the early developments. There is research happening in this space. You can try a potential neutralization, but you will need to balance it and then test what you get, so you don't introduce another hazard by neutralizing it, and then you have another material in the water that you need to still deal with. But my understanding is that both the ABS and the DNV rules have taken into account this hazard in the development of their requirements for ship anchoring. Obviously, there's always the chance of things not going well.
Excellent. Yun Liu from the Hong Kong Polytechnic University asks that if ammonia is used in big cities like in gas power stations, how can you prevent leakage there and harmful effects in those built up areas?
Yeah, okay. So in an industrial concept and context, and this is what's currently being done, the best mitigation for an ammonia vapor release is through the use of fine water mist. So it's pipes with nozzles set around your storage area, and then if there's a leak identified, then it's activated and it provides neutralization of these leaks. So this is the common way it is controlled, but then I do not foresee ammonia being used on such small scale projects like gas stations and such, because of this toxicity hazard. So this is where hydrogen stacks up better in comparison to ammonia.
Okay, excellent. I should add there as well that Krista said that the AEA should be developing a best practices safety guide, and with your suggestion of a safety conference or symposium, I think we've got a lot of very, very fruitful content to work through and to offer people. So I will definitely go away and start some more plans for those sorts of things, which is excellent. A few more questions, then we'll wrap. Ron Graves, who's here, asks, who's here live, asks, if you're using hydrogen as a pilot fuel in your ammonia, are there different safety considerations or regulations that you have to follow?
Well, yeah, there will be, because the hazards, and again, in terms of regulatory requirements, it varies based on the location where you are in the world. In Australia, we use this tier of different stored quantities. So if you go above a certain tier, there's more regulatory requirements and such. So you may have ammonia, let's say at a low tier, but then you'd have hydrogen at a higher tier. So it can trigger different regulatory requirements. And yes, obviously the hazards are different for each material. Hydrogen is flammable and explosive, where ammonia is less, but then it's toxic. So you would need to manage both of them. It would obviously be easier because you'd be using a small quantity of hydrogen just being for a pilot light.
Excellent. We'll finish up with one more question. Thank you very much for staying a bit longer. This is a wonderful conversation. This is from Thomas Jam Peterson in Denmark, from Copenhagen Atomics. Safety protocols end up nice to have, not need to have. Do you know of any studies that look at the cost of those individual safety items?
Okay, nice to have versus need to have. So definitely the regulator, and in this case, if we're talking maritime application, the regulator and the classification societies play a big role in making those standards and requirements mandatory, and then also verifying that they have been implemented to grant, a permit or a license, depending on your regulatory requirement. The maturity of the client and the designer also plays a huge part in it, of how much those studies and activities actually get done versus not. So if we're talking about the cost, is that our experience is that safety requirements are around 10% of the overall project design cost. So this is just a project design cost. We're not talking about fabrication. We're not talking about operation. That one you can see as, I guess, something affordable. And then if you take it into account from the initial stages, then you're far better. The actual cost of control measures varies a lot based on application, worldwide location, and such. So I don't know of any of such studies, but also with this one, with safety protocols not being implemented, is our experience is that when they are not implemented, it is not out of ill will, but because they've been identified too late in the project, and correcting them at a very late stage of the project is costly and requires a lot of engineering rework, and this obviously draws schedule and cost problems.
Excellent. And I think that's a good message to end on. We need to be better from the get-go and be very proactive at the start.
Yeah,
Excellent.
definitely.
Excellent. Well, thank you very much, Laurentiu. Thank you to our audience. That will be a wrap for this month's episode of Ammonia Energy Live. Thank you very much to everyone for coming along. Stay tuned for details of our May episode. I don't have the speaker yet, but our next Maritime Ammonia Insights webinar will stick with the safety theme, and we'll welcome representatives from both the Global Centre for Maritime Decarbonisation and DNV to discuss their exciting ammonia bunker study, including the accidental release of ammonia on water. So very, very hot topic. It'll be good to follow that up. We'll be doing that at 10 a.m. CET on Thursday, 24th of May, which is just after dinner for us here in Australia. It'll be a terrific discussion. Registration details via our newsletter and LinkedIn. We'll also launch our next Project Features webinar soon, where we'll pay a visit to North America and look at some low carbon ammonia production there. Thank you very much to Laurentiu for being our guest today, and we'll see you all next month on Ammonia Energy Live. Thank you. That was great.
Thanks for having me, Julian, and to our attendees. Have a good day.